Hello students, welcome to memoneet. This is Ravikant, your physics teacher, and today we will be discussing the solution of your BPT 19 question paper. Hope you all are doing well and you must have availed the highest discount which has been going on for the memoneet courses, right? So please go and avail those discounts and let's discuss BPT 19 physics question paper, right? The very first question says that a steel wire of length 0.75 meter has mass of 5 into 10 to the power of minus 3 kilograms. If the wire is under a tension of 60 Newton, then the speed of transverse wave is. So see, what we are supposed to use here is that the speed of the transverse wave is being given by the formula V is equals to under root of T upon M, where T is the tension and M is the mass per unit length, right? In the question they have given us mass and they have also given us the length. When we divide the two, we'll get the value of small m, which is mass per unit length, right? And the tension is your 60, right? 60 Newton will be your tension in the string. So putting the value in the formula, in place of 60, we'll get V is equals to under root of tension we'll put as 60 and mass per unit length. So mass is 5 into 10 to the power of minus 3 and into 0.75, right? Calculating this and then finally getting the answer as 3 into 10 to the power of 30 into root 10 meter per second. This is the speed of the right. So putting the values, we get your speed as 3 into root 10 meter per second, and according to this the correct answer for question number 1 is your option 1. Coming to question number 2, question number 2 says that the shortest distance traveled by a particle executing SHM from an extreme position in 3 seconds is equal to half of its amplitude. The time period of the given particle is. So here they say that for t is equals to 3 seconds, your x is equals to a by 2, and we have the formula x is equals to a cos omega t, So now putting the values, x is equals to a by 2 and t as 3, we have solved here. We can see from here that when we put x is equals to, in the formula x is equals to a cos omega t, when we put x is equals to a by 2 and t is 3 seconds, right? So this is omega and this is t as 3 seconds. Solving this will give you 1 by 2 is equals to cos 6 pi 2 pi by t into 3, right? And then solving this will get your capital T is equals to 18 seconds. That is the time period of the oscillation is equals to 18 seconds, right? The correct answer for question number 2 is also your first option. Option 1 is the correct answer for question number 2. Coming to question number 3, the radius and the acceleration due to gravity of a moon are 1 by 4 times and 1 by 5 times 1 by 5 times, yes, 1 by 5 times 1 by 5 times the of earth. The ratio of the mass of the earth to the mass of the moon is. So what they say that the radius of moon is equals to 1 by 4 times the radius of earth. And what else they say that the mass due to an acceleration due to gravity, that is g on moon is equals to 1 by 5 times of acceleration due to gravity on earth, right? So the ratio of the mass of the earth to the mass of the moon. See, your acceleration due to gravity g is given by gm upon r square, right? G upon m upon r square. So g of earth upon g of moon will be equals to mass of earth upon mass of moon into radius of moon square upon radius of earth square, right? This ratio has been given to us as 5. Yes, from here we can say G upon GE upon GM is equals to 5. Then mass of earth upon mass of moon we need to calculate. that is me upon mm into radius of moon upon radius of earth is equals to 1 by 4. So taking its square root will become 1 by 16. So when 16 goes here, we get m1 upon me here. Me upon m is equals to 80 is to 1. So the correct answer for question number 3 is 80 is to 1. That is your second option. So the correct answer for question number 3 is option 2. Now coming to the fourth question. Fourth question says the relation between the velocity and the displacement of the particle. Velocity and displacement of the particle has been given to us is this like this. Then find the time period of the oscillation. Right. So when they have given to us as 4v square is equal 4v square is equals to 25 minus x square. So we know that v is equals to omega under root of a square minus x square. This is the formula which we are supposed to use here, right? Yeah, what? V is equals to omega under root of a square minus x square. Now we have this equation over here. We can taking squaring both the sides, and we can write it as v square is equals to omega square into a square minus x square, right? So rearranging the given equation, we will get your v square is equals to your 25, or let me write it as 5 upon 2 whole square minus x by 2 whole square, x by 2 whole square, right? So solving this and comparing, here we can see your omega square is coming as, no, wait, right, we will write it as v square is equals to 1 by 4 into 25 minus x square. So in place of omega square we are having 1 by 4. So omega square is equals to 1 by 4. So we'll get omega is equals to 1 by 2. What they are asking, find the time period of the oscillation. They're asking the time period. If omega is equals to 1 by 2, so 2 pi by capital T is equals to 1 by 2. So your time period will be equals to 4 pi seconds, right? Now coming to question number 5. Question number 5 says, so correct answer is option 4. Sorry. For question number 4, your correct answer is option 4. Right. Now coming to question number 5, it says a planet moving around the sun sweeps area A1 in 3 days, area 2 in A2 in 6 days, and area A3 in 2 days. The relation between A1, A2 and A3 is, according to the Kepler's law, the rate of change of area, that is the area swept, remains constant, right? Remains constant. So it means your A1 is covered in 3 seconds, should be equals to A2 upon 6, should be equals to A3, should be equals to A3 upon, yeah, A3 upon A3 upon 2. Now finding the LCM and solving it, we get what? Your 2 times of A1 plus, sorry, is to A2 is to 3 times of A3, right? We can see it from here. So A1 upon 3 is equals to A2 upon 6 is equals to A3 upon 2, and solving this we get 2 times of A1 is equals to A2 is equals to 3 times of A3. So we have the solution as option number 3. So the correct answer for question number 5 is option 3, right? Now coming to the next question. So now let's see what next question says, and the next question says, question number 6 says that the statement 1 says that a steel bar can propagate longitudinal as well as transverse wave. All right, and second statement says that air can propagate only longitudinal wave. Both upon based upon the statement information, choose the correct answer. So see, we have to choose which of these statement is correct. So see, both the statements are correct, because in a steel bar both the waves, transverse wave and longitudinal wave, both of them can move. And then a longitudinal wave, air has only longitudinal wave because it cannot have your transverse wave. So both the statements are correct, and for that we have your option 3 in this, that is both statement 1 and 2 are correct, right? So next, coming to question number 7. Question number 7 says that consider a uniform spherical, sorry, uniform solid sphere of mass 10 kg and radius 4 meter. G represents the universal gravitational constant, and R is the distance from the center of the sphere. Using the above information, match the column and mark the correct options. All entries in column 2 are in SI unit. So, gravitational field at the r is equals to 20, r is equals to 5. See, gravitational field has been given as your gravitational field is equals to your g m upon r square, right? So g m upon m is 10, g m upon r square, r is your 4 meters upon 16, right? So this would be equals to 2528. So 5 by 8 g, we sorry, 5 by 8 g, हाँ नहीं है क्वेश्चन नंबर, दिस इज क्वेश्चन नंबर 7, क्वेश्चन नंबर 7, right? Gravitational field E is about 5 by 8, 25 na, what I've done, it's r is equals to 5, field outside the sphere, this, therefore r is equals to 5, r is equals to 5, right? So 25 na, so I've taken 4, we'll take it as 25 here. So 10 upon 5 2s are, and 5 5s are, so 2g upon 5, right? 2g upon 5, and 2g upon 5 is 2g upon 5 is an option S. So this is for A. So A with S is in option 1, A with S is in option 4. We have to see some more options. Then second, it says the gravitational field at R is equals to 2. So gravitational field at R is equals to 2 will be equals to G 10 upon 4. That is your 5 by 2. That is 2.5. 5 by 2. 5 by 2. 5 by 16. Wait a minute. Inside, not inside. Okay, it's inside. So it will be your G M R upon R cube. G M R upon R cube. R upon R cube. R cube. R is your 2. 2 and R cube is your 4. 4 is your 16 and 16 and 64. Right. So, and here it's 10. So 2 ones are 2. 2 ones are 232 and 2 5 to 16. So 16, here it is. So we have B. So with B we have P. So this correct answer is option 4. The correct answer for question number 7 is option 4, right? We only the two, checking for only 2 we will get the correct answer, right? If you want, you can check for the rest of the 4 options. Next, coming to your question number 7 is done. Now coming to question number 8. Question number 8. Question number 8 says that a differential equation representing the SHM of a particle is 25 d2y upon dt square plus 9y. 9y is equals to 0. The time taken by the particle to travel from y is equals to 0 to y is equals to a by 2 will be. Okay. So we can see here is d2y plus d2y upon dt square, that is twice the differentiation of y plus omega square y is equals to 0. This is the differential equation which represents SHM, right? This represents SHM, where x is the displacement of the particle and, sorry, y is the displacement of the particle, and omega is the SHM speed. Now the given equation is 25 d2y upon dt square is equals to 9y equals to 0. Now when we compare with this equation, what we have to do is we have to make the coefficient of d2y upon dt square as 1. So we divide the whole equation by 25 and we get d2y upon dt square is equals to 9 upon 25y equals to 0. So from here, comparing the equation first and equation second, what we get is omega square is equals to 9 upon 25, from where we can say that your omega is equals to 3 upon 5. Right now, omega is equals to 3 upon 5. The time taken to travel from y is equals to 0 to a by 2. So in the equation y is equals to a sine omega t, we put y is equals to a by 2. Solving this, we get omega t is equals to pi by 6. Right now, we have omega t is equals to pi by 6 and we have omega s 3 by 5. Putting the value of omega, we get t is equals to 5 pi by 18. 5 pi by 18. So we have this in your option 3. So the correct answer for question number 8 is option 3. Right? Simple formula based question. Next, coming to your question number 9, it says the transverse displacement of a string clamped at both the ends. Clamped at both the ends means two nodes and one antinode is giving y x comma t is equals to 0.06 sine 2 pi x by 3 cos 120 pi t, where x and y are in meter and t seconds. The ratio of the amplitude of the particle 1.5 meter away from one end of the particle and 0.375 meter away from the same end, considering the length of the string to be 1.5. Right. So in question number 9, they have given us is the standard equation. So the equation for the wave is y x comma t is equals to 0.06 sine 2 pi x by 3 into cos 120 pi t. Right now, putting x is equals to 0.375 and t is equals to 0, and also putting x is equals to 1.5 at t is equals to 0. Right, at t is equals to 0, we are calculating, see they what they are asking the ratio of the amplitude of the particle at 1.5 and at 0.375. So we are taking same time for the two different positions, that is t is equals to 0, t is equals to 0 for x is equals to this and x is equals to this. Putting the values, we get a1 is equals to 0, that is amplitude of 1 is equals to 0. No, we get a2 as 0. Wait a minute, when you put it as for yes, for x is equals to 0.375, putting x is equals to 375, 0.375 and t is equals to 0, we get amplitude as your 0.042. Whereas when we put x is equals to 1.5 at t is equals to 0, obviously if the length of the string which is fixed at two ends is of 1.5, then definitely at that point it would be a node. Right, there will be a node formation, and if it's a node formation, then the amplitude will be equals to 0. Right, amplitude will be equals to 0. Now if the amplitude of one of it is 0, so the ratio of a1 upon a2 will definitely be equals to 0. So the correct answer for this question is option 1. No need to do so much calculations. Right, simply if you can observe from here that the length of the wire is 1.5, right, and the wire is stretched, that is clamped at its both ends. It is clamped at both ends, length is 1.5. So if the wire is clamped at both ends, this would be the thing, this would be the case. Right, this would be the case, this length will be equals to your 1.5 meter. Right, this will be the node, this will be the node, and this would be the antinode. Right, so at any time the amplitude of this point would be 0. Now if this point is amplitude of this point is taken as a1, then a1 upon any of the amplitude would give you the ratio as 0. So the correct answer will be 1. Right, so correct answer is question number 9 is 1. Now coming to question number 10. Question number 10 says a simple pendulum has length L, mass of bob m. The bob is given a charge q coulombs. The pendulum is suspended in a uniform horizontal electric field of strength E as shown in the figure. Now then calculate the time period of oscillation when the bob is slightly displaced from the mean position. See, the thing is, when it has been placed in an electric field, there are two forces acting on the bob. So this is the bob. This is the direction of electrostatic force, and this is the direction of the weight acting on it. Right? This is mg. Now, the effective acceleration due to gravity would be this. This would be g effective, right? This would be G effective. Now, if this would be the G effective, and we have the formula P is equals to 2 pi under root L upon, here we will write G effective. Calculating the G effective and putting the value, we have L, we calculate G effective, and when we put, we will get the value of time period here, right? So, let's see the calculations for it. See, here, this is the diagram. Here we have the electrostatic force, here we have the weight, and this is the G effect, is the resultant force acting on the bob. Now, if this is the resultant force acting on the bob, we divide it by m. If I divide it by m, I'll get the effective acceleration due to gravity. I'll get effective acceleration due to gravity, right? So, see, G effective is equals to, this is the resultant force upon m, will give you the effective acceleration experienced by the bob. Now, putting this in time, the value of time period, and solving it, we will get T is equals to 2 pi under root L upon G square plus Q E upon M square. So, this is your option 4 in the question. Option 4 in the question. It's nothing but simply putting the values. No calculation, no such difficult calculation. The only thing is that you should remember, the two things that you should remember here is that the time period of a simple pendulum has the formula T is equals to 2 pi under root L upon G. So, because of this electrostatic force, what has been affected? That is the acceleration due to gravity experienced by the bob has been affected, and you need to calculate it. Now, putting that calculated G effective in the formula, you will get the time period, right? Now, coming to the question number 11. Coming to question number 11, the question number 11 says, question number 11 says, a wire stretched between two grids. Wire stretched between two grids supports vibration in the fundamental mode with a frequency f0. If the mass of the wire is m and the linear mass density is equals to lambda, then the tension in the string is. See, when the wire is stretched at two ends, same like this, then the length of the wire is equals to lambda by 2, right? Length of the wire is lambda by 2, where here the lambda is the wavelength, not the mass density. Here in the question, just to confuse, they have taken mass density as lambda, right? Now, let's say here, see, when mass is m and linear mass density is lambda, then length is equals to m by lambda, right? Because lambda is mass per unit length, so L will be equals to m upon lambda. Now, fundamental mode frequency f naught. F naught is, means frequency is being given by velocity upon wavelength, right? So, for the fundamental frequency, wavelength is equals to 2L. Wavelength is equals to, that is, lambda is equals to 2L. Lambda means wavelength here, right? That is, L is equals to, what I've written here is L is equals to lambda by 2. It means lambda is equals to L is equals to 2L. Getting the point? From this figure, we can see that the length of the wire will be equals to half the lambda. Half the lambda. It means lambda will be equals to twice the length. Now, we have the formula frequency is equals to wave velocity upon wavelength. Wave velocity, yeah, so your wave velocity is equals to tension upon mass density, right? Tension in the wire is being given to us. Wire's fundamental frequency is twice the wire. Okay. No, tension is not being given to us. So F naught. Okay. We have to calculate tension, right? So putting the values, that is your F naught is equals to wave velocity upon wavelength. So wave velocity is tension upon mass density. So tension upon mass density, under root of tension upon mass density. This is your wave velocity, and this is your wavelength. Putting the values, we finally get, and rearranging it, we finally get our tension is equals to T is equals to 4 F naught square m square upon lambda. So 4 F naught square m square upon lambda, which is in your option 2, right? Getting the point? See, wave velocity V is equals to your under root T upon mass density, that is lambda over here, right? What else? The fundamental frequency F naught will be equals to your wave velocity upon wavelength. So what is the wavelength over here? Wavelength is equals to 2L. Wavelength is equals to 2L, right? Now putting the value of V over here, what we'll get? Putting the value of V over here, we will get let me write it, let me write it here. We will get F naught, is equals to 1 by 2L into under root of T upon lambda. Now rearranging this for T, squaring both the sides and rearranging for this for T, we will get our T is equals to F naught square 4 L square lambda, right? F naught not upon lambda, right? Let me recheck it. 1 upon 2L. So lambda will go and multiply here is 2L. Right. Some mistake is in done. Okay. In place of L is been written as m by lambda, right? L is written as m by lambda, so you'll get T is equals to F naught square 4 into 4 into m square upon lambda square into lambda. So this lambda and this lambda goes off. Finally, what we are left with is T is equals to 4 F naught square m square by lambda, right? This is how you are getting. So if you have understood, the basic thing is, if you get this, you can rearrange it and putting the value of L, you will get the answer. The correct answer for this question is option 2. Option 2, right? No mistake has been done. Correct. Now coming to question number 11, sorry 12, question number 12. Question number 12 says the time period of the revolution of a satellite around a planet of radius r is t. The period of revolution around another planet whose radius is 3r but having the same density is, right? So for this you will have to remember the formula for time period of revolution in terms of density and radius, right? So that formula is your this, that is T is equals to 2 pi r raised to the power of 3 by 2 upon under root gd upon gd into 4 by 3 pi r cube, right? From here what we conclude is that time period square is proportional to 1 by radius cube if the density is same, right? If the density is same, then this is the relation which we have, right? So it means that T2 upon T1 whole square is equals to R1 upon R2 whole cube. Now we know that R1, if R1 is R, then R2 is equals to 3 times of R, and if T1 is T, we need to calculate T2. Putting these values in this and calculating, we get our final ratio as as T2 is equals to T by 3 root 3. That is T2 is equals to T by 3 root 3, and this we have in your option 1. Right, this we have in your option 1. What is the relation we are using is, that is T2 upon T1 whole square is equals to your R1 upon R2 whole cube, right? T2 we need to calculate, T1 is taken as T, R1 is R, and R2 is 3 times of R. Solving this, you get T2 is equals to T upon 3 root 3, right? So the correct answer is option 1. Coming to question number 13. Question number 13 says that a graph below shows variation of amplitude of the forced oscillation with respect to the frequency of the driving force. Choose the correct option. This is the graph they have given. The amplitude is maximum at omega d is equals to omega naught, right? Okay. Then the peak value ठीक है, ये तो रेजोनेंस वाला केस हो गया. देन पीक एम्पलीट्यूड इज मैक्सिमम फॉर कर्व ए, बिकॉज ऑफ कर्व ए डैम्पिंग इज मिनिमम. If damping is minimum, amplitude will be maximum. In case of resonance, there occurs maximum transfer of energy from driver to the driven. Yes, so all the above options are correct. So the correct answer for question number 13 is option 4, right? Question number 13 is option 4, right? Question number 13, the option is correct answer is option 4. That is all the above statements are correct for the given graph, right? Now coming to question number 14. Coming to question number 14. Question number 14 says that a body is projected vertically upwards from the surface of the earth with a speed equal to 1 by 4 of the speed of the escape velocity from the surface of the earth. Now maximum height attained by the body from the surface of the earth will be, where r is the radius of the earth. Okay, so escape velocity on the surface of the earth. Okay. Escape velocity from the surface of the earth is 11.2 kilometers per second. So the velocity of projection is equals to 1 by 4 times of escape velocity, and the escape velocity is given as under root g m upon ve is equals to under root 2 g m upon r, right? This is the formula for escape velocity. Now we know by the law of conservation of energy that the potential energy and kinetic energy at the initial position will be equals to potential energy plus kinetic energy at the final position, right? So the potential energy at the surface of the earth is equals to minus g m upon r, and the kinetic energy is equals to half m v square. This v is 1 by 4 times of escape velocity. Then it attains the maximum height of h. Then at that position the kinetic energy will be equals to 0, but the potential energy will become equals to minus g m upon r plus h, right? Minus g m upon r plus h. This would be the potential energy at the maximum height, right? Now solving this and putting the values, that is putting the value of v as we have v as 1 by 4 times of escape velocity, and rearranging and putting the values over here, we finally get h is equals to r by 15. That is the height attained will be equals to r by 15. So we have this in your option. R by 15 is in the option 4. Option 4. So the correct answer for question number 14 is option 4. What we have done, simply we have put the value. See, g m upon r is equals to half m, and this is the value of v square. V square is equals to, see, 1 by 4 ka square is 1 by 16, and this is ve ka square, that is square of under root g 2 gm upon r. Under root 2 gm upon r ka square we will do, we will get 2 gm upon r, right? And then minus gm upon r plus h. Solving this will get h is equals to r by 15. So correct answer for question number 14 is your option 4. Coming to question number 15. Question number 15 says, from a damped oscillation, the graph between the square of the amplitude of oscillation and its time is best described as, right? So for the damped oscillation, amplitude goes on decaying exponentially. See, it decays exponentially, so it has been given by this equation, that is a is equals to a naught into e raised to the power of minus gamma t, right? Minus gamma t. Now, if it is decaying exponentially, see, exponentially decaying graph is this. This is exponentially decaying graph. This is not. This is a linearly decaying graph. This is a constant graph, and this is it's also decaying graph, but it's not actually decaying graph, because at a point it is becoming zero, right? In a decaying graph, it never comes to zero. It is asymptotic, right? So the correct answer for question number 15 will be option 2, right? Because it is decaying exponentially. Next, coming to your question number 16. Question number 16. Question number 16 says that a particle executes linear simple harmonic motion with an amplitude of 3 centimeters. When the particle is at 2 centimeters from the mean position, the magnitude of the velocity, its velocity is equal to the to that of its acceleration, then its time period in seconds is. Okay, now see, when the particle, see, it's a simple harmonic motion, has amplitude, that is value of a is equals to 3 centimeters, value of a is equals to 3 centimeters, then value of x, that when the particle is at 2 centimeters, so value of x has been given to us as 2 centimeters. From the magnitude of the velocity. The magnitude of the velocity is equal to the magnitude of the acceleration. So for SHM, we have magnitude of acceleration as a is equals to minus omega square x. So its magnitude will be equals to omega square x, right? And so we can put this omega square x as v, and v is being given by omega under root of a square minus x square. It means according to this question, omega under root of a square minus x square, that is the magnitude of the velocity, is equal to the magnitude of acceleration, that is omega square x. Omega square x. So we have equated it here and we have put the value of x, a, and then finally we have calculated omega, and from omega, because omega is equals to 2 pi by t, putting the values we get rt as 4 pi by root 5. 4 pi by root 5 is your option 3, right? So the correct answer for question number 16 is option 3. Simply equating the formula for velocity with the formula for acceleration, putting the given values and calculating it for the time period, you will get the value as 4 pi by under root 5. Next, coming to question number 17. Question number 17 says that the radius of a planet R, planet is R, a satellite revolves around it in a circle of radius R, small r, with an angular velocity omega naught. The acceleration due to gravity of the planet surface is given by. See, here again the concept of centripetal force will be coming in picture. Let the mass of the planet and the satellite be m and small m. This is the mass of planet and small m is the mass of the satellite. Now the gravitational force acting on the satellite and on the planet is equal to the centrifugal force acting on the satellite. Therefore, m omega square r, the centrifugal force, is equals to the gravitational pull, gmm upon r square. Equating this, we know that the acceleration due to gravity for a given surface is gm upon r square. So from here we get gm is equals to g at the planet into r square. So putting gm, here we put gm as g of the planet into r square. So g of the planet into r square into m upon small r square is equals to m omega square r square. Solving this, we get g on the planet is equals to omega square into r cube upon r, which is the option omega naught square r cube upon r square. The option 4, right? The question for question number 17, the correct answer is your option number 4. Again, it was simply the formula based question. Coming to question number 18, the fundamental frequency in an open organ pipe is equal to the fifth harmonic of, hold on, the fundamental frequency in an open organ pipe is equal to the fifth harmonic of the closed organ pipe. If the length of the open organ pipe is 10 centimeter, then the length of the closed organ pipe will be. Again, just to remind you, for an open organ pipe, this would be the case. There we have antinode, here we have node, and then we have antinode, right? And the length of the organ pipe will be equals to lambda. Yes. So lambda by 2, no? Lambda by 2. Yes, lambda by 2. And for a closed organ pipe, the case would be, for a closed organ pipe, the case would be like this. Here we have antinode and here we have node, and length of the organ pipe will be equals to lambda by 4, right? So what they are saying that the fundamental frequency of an open organ pipe is equal to the fifth harmonic of the closed organ pipe. All right. So the fundamental frequency for the open organ pipe is given as 1 by 2L. What they have written. And the frequency of the fifth harmonic will be equals to 5 by 4 F by 5 by 4 F by L, right? So see, try to understand it like this. As I've shown in the figure, as it is being shown in the figure by me, that for a closed organ pipe this is the case, and for an open organ pipe this is the case. What we can see or what we can write from here is the fundamental frequency F naught for a closed organ pipe will be equals to, see, V upon your lambda, right? V upon lambda. So what is lambda? Lambda is, from here we get lambda by 4 is equals to L. So lambda is equals to 4 times of L. So for a closed organ pipe, if I take length as L dash, so the for closed organ pipe, the fundamental frequency F naught will be equals to V upon 4 times of L. 4 times of L, and fifth harmonic will be equals to F5 will be equals to 5 times of V upon 4L, right? Coming to the open organ pipe, from here we can say your lambda is equals to 2 times of L. So your fundamental frequency F naught will be equals to your V upon 2L, and for the open organ pipe they have given that the for open organ pipe the length of the pipe is 10 centimeters. So if we put L is equals to 10 over here, we get your fundamental frequency F naught is equals to V upon 20. And what they say that this fundamental frequency is equal to the fifth harmonic of the closed open pipe. So for according to that, we can write that 5 by 4 V by L dash, V by L dash is equals to V upon 20, right? So V and V cancels out. 5 ones are 5, 4 5s are. So from here we get your L dash is equals to 25 centimeter, right? So the correct answer for question number 18 is your 25 centimeter, which is option 3, right? Which is option 3. Now coming to your question number 19. Question number 19 says that two particles are oscillating along two closed parallel straight lines side by side with the same frequency and amplitude. They pass each other moving in opposite directions when their displacement is half of the amplitude. The mean position of the two particles lie on a straight line perpendicular to the path of the two particles. The phase difference is, okay, they are asking you the phase difference. What they are saying is, see, there are two particles which are there are two particles oscillating along the closed. See, the lines are parallel, straight line side by side with the same frequency and amplitude. The frequency is omega here, so again it is omega here. What is the amplitude? Amplitude is A, so here also the amplitude is A. They pass each other moving in opposite direction, means they are passing each other. Suppose at this point there, that is this is the point of A by 2, and this point they are passing. So one of the particle was moving towards the right, then the other was passing towards the left, right? This was a phase difference between them, which we have to calculate. And they are passing in opposite direction with their displacement, when their displacement is half of the amplitude, that is at the position of A by 2 they are passing each other, and while they are passing each other the direction of motion is opposite of each other. So if this is the case, then what is the phase difference between them, right? So see, you can understand it from here that V1 is equals to A omega cos omega t, right? A omega cos omega t. Therefore, V2 is equals to A omega cos omega t plus phi, because there is a phase difference in the velocity, right? One's velocity is in this direction, another's velocity is in this direction. So definitely there is a phase difference in the velocity. Now, amplitude is A, omega is the angular speed, and phi is the phase difference in this. Then According to the question, they say that the move in the opposite direction, that is v1 is equals to minus of v2, right? v1 is equals to minus of v2 when x is equals to a by 2. So when x is equals to a by 2, you will get what? Omega t is equals to pi by 6. You put x is equals to a by 2, that is x is equals to a cos omega t, right? X is equals to a cos omega t. You put a by 2, you will get omega t is equals to pi by 6. Sorry, sine, na? Sine omega t, because here they have taken cos, so it will put sine. So you will get x is equals to, omega t is equals to pi by 6. So putting omega is equals to pi by 6 here, right? Now we have v1 minus v2, v1 is equals to minus of v2. So here we have v1, this is v1 minus v2, a omega cancels out, cos omega t is equals to minus cos omega t plus phi. Omega t we know have the value of pi by 6. So putting the value of pi by 6 and solving it by putting the values, finally we get phi is equals to 2 pi by 3, right? See, here the values have been put and we finally calculate it and get phi is equals to 2 pi by 3, which is the correct answer, and the correct answer is your 2 pi by 3, which is option 4, right? So the two things which we have done over here is, the very first thing is V1 is taken as a omega cos omega t, then V2 will be equals to a omega cos omega t plus phi. This would be V2, and according to the question, V1 is equals to minus of V2, and at position x is equals to a by 2, and for x is equals to a by 2, you will get omega t is equals to pi by 6. Equate v1 and v2 and put the values, you will get pi is equals to 2 pi by 3, which is your option 4 for question number 19. Coming to question number 20. Question number 20 says that assertion and reason. The assertion says for a satellite revolving very near to the Earth's surface, the time period of the revolution is given by 1 hour 24 minutes. Reason: the time period of the revolution of the satellite depends upon the height above the Earth's surface. The revolution of the time period of revolution. The time period of the revolution of the satellite depends upon, no, it does not depends upon the height of the height above the Earth's surface. So reason is not true. So for reason not true, we have both assertion and reason are true. No, both assertion and reason are true, but reason. So if assertion is true but reason is false, assertion and reason both are false. See, reason is false. Now coming to the assertion, for a satellite revolving very near to the Earth's surface, the time period of the revolution is given by 1 hour 24 minutes. This is correct. So according to this, the correct answer will be option 3. That is, the assertion is correct, but reason is false. Now, if we look into the calculations, it is the time period for every satellite which is very near to the Earth's surface, given as t is equals to 2 pi under root r by g, capital R by g, right? Now, putting the value of r, that is 6400 meter, right? Kilometer. 6400 kilometer is the radius of the Earth. Putting this value and putting the value of acceleration due to gravity, we finally get our answer as 1 hour 24 minutes, which is correct, right? Which is 1 hour. See, here the calculations are being done, and we got it as 1 hour 24 minutes. But and from the from the formula itself, the t is equals to 2 pi under root r by g. Here we do not have the height above the Earth's surface, right? So the reason is wrong. So for this question number 20, the correct answer is option 3. That is, the assertion is correct, but reason is wrong. Next, coming to question number 21. Question number 21 says that the speed of a sound in air at NTP is 332 meter per second. If density of the hydrogen at NTP is 1 by 6, then the air 1 by 16th of the air, then the speed of the sound will be. See, here we are handling with the air. So in air, the speed of velocity of sound is given by v is equals to gamma p by rho, right? P by rho. Now, because both the gases are at NTP, right? We are talking at NTP, so P is constant, right? P is constant, and gamma is also taken as constant here. So we will get that velocity of sound is proportional to 1 by under root rho. 1 by under root rho. That is, we can say that velocity in air upon velocity in hydrogen will be equals to under root of density of hydrogen upon density of air. So from the question we can say that they are saying that the density of hydrogen is 1 by 16th of air. That is, density of hydrogen is equals to 1 by 16th of density of air. So density of hydrogen upon density of air will be equals to 1 by 16. So we'll get VA upon VH is equals to under root of 1 by 16. Under root of 1 by 16. So finally we will get VA upon VH is equals to 1 by 4, and VA has been given as 332. So 322 when multiplied by 4, we will get 1328 meter per second, and this is how you will calculate the velocity of sound in hydrogen, right? This is given as 332, multiplying 332 by 4 will get velocity of hydrogen, that is 1328. 1328 the correct answer. The correct answer is option number 3. The formula used in this question is V is equals to V is equals to under root gamma T by rho, because of your NTP taken, right? Constant temperature and constant pressure. The gamma, that is the Cp by Cv, gas and pressure. These two, the numerator quantity is constant, and therefore we get V is proportional to root of density. So the correct answer for question number 21 is option 3. Coming to question number 22. Question number 22 says that in a simple simple harmonic motion, when the displacement is one half the amplitude, what fraction of the total energy is kinetic energy? Okay, so when in a simple harmonic motion, when x is equals to a by 2, see, in some intermediate position, the total energy is given by half k of a square minus x square. This is the total energy, whereas total kinetic energy at an extreme position, sorry, at the mean position is given as half ka square, right? Half ka square, half ka square. Now they are saying that we have to find at x is equals to a by 2. So in this, when you put x is equals to a by 2 and solve it, what you will get is your 1 by 2 k into a square minus a square by 4, a square by 4, right? And this is equals to half k a square. So from here we'll get half into 3 by 4 a square is equals to half k a square. So we can say that your total kinetic energy, and this is your intermediate energy, and this is equals to 3 by 4 times of your kinetic energy. So ratio will be equals to 3 is to 4. So the correct answer will be option 2, right? Because this half ka square is total energy, and what we find is this, that this energy at this intermediate position is equals to 3 by 4th of the total energy, right? 3 by 4 of the total energy. So from here we get the ratio as 3 by 4. Getting a thing? So this is your total energy, and this is your energy at some position. So if total energy is half ka square, and calculating this we get 3 by 4 times of ka square, half ka square. It means intermediate position we have energy as 3 by 4 times of total energy, right? So the correct answer is option number 2. Coming to question number 23. Coming to question number 23. Question number 23 says that three consecutive resonance frequency is of a stretched string fixed at both ends are 60 hertz, 90 hertz, and 120 hertz. Then the fundamental frequency is 30 hertz. These are consecutive, na? See, these are consecutive and then fixed at two ends. When it is fixed, it means see F is equals to V by 2L for fixed, right? Now for fixed, if this is the thing, then your n frequency, that is nth V by 2L is equals to 60. This is what has been given to us. Have they given? Right. So fundamental frequency will be, if we cancel this, okay, now this is n, and the next is your is n plus 1th into V by 2L is equals to 90, right? So when we subtract these two, what will get? V by 2L is equals to 30. This is the fundamental frequency, right? If this is the fundamental frequency, this is the first overtone, this is the second overtone, this is the third overtone, right? This is the third overtone. So what they are saying is the fundamental frequency is 30 hertz, right? The given frequency are first, second, first, third, and fifth harmonic. No, it is the given frequencies are first, second, and third overtone. Yes, so both first and third are correct. So the correct answer for question number 23 is option 4, right? So correct answer is option 4. So option, wait a minute. Question number 23, correct answer is option 4. That is both first and third are correct. Now coming to your question number 24. Question number 24. Question number 24 says that the 2-point masses having mass m and 4m are placed at a distance r. The gravitational potential at a point where the gravitational field intensity is 0. Okay. So if this is m, this is 4m, and randomly we have taken any point which is at a distance x from m, and the distance between the two masses is r. So from here we can say that the question says that 2-point masses having this is the gravitational potential at a point where the gravitational field intensity is 0. So first we will calculate position at which the field intensity is 0, and let it be the point P, which is at a distance x from m. So field intensity because of small m will be equals to gm upon x square, and because of 4m will be equals to g into 4m upon r minus x whole square, because this distance is r minus x. So r minus x whole square. Equating this, finally we get x is equals to r by 3. That this distance is equals to r by 3. And now at this position we need to calculate potential. So calculating potential, the potential at point P will be equals to gm upon x minus g 4m upon r minus x. We have x is equals to r by 3. Putting the value of x as r by 3 here and solving it, we get the potential at this point is minus 9g m upon r, minus 9g m upon r, which is option 1, right? Which is option 1. So simply it is formula based question, that is intensity at a point is given by gm upon r square, and intensity at any point is been given by gm upon r, right? So here at point P the intensity is 0, so intensity because of smaller mass will be equals to intensity because of heavier mass. Solving it, we get the position at x is equals to r by 3. Then calculating potential at this point, we simply add the potential because of the two masses, and that potential adds on and gives us as minus g m upon r, right? So the correct answer will be your option 1. Coming to question number 25. Question number 25. Yes. Now the equation of two progressive waves is given by y1 is equals to a sine kx minus omega t, and y2 is equals to a sine kx minus omega t plus theta. Means the two waves are having an angle phase difference of theta, right? Now then the amplitude of medium particle will be. So see, the medium particle is experiencing both the waves at the same time. It means, sorry, both the particle is experiencing both the waves at the same time. So if you look at this diagram, we can say that this is the particle and it is experiencing both the amplitude at the same time. So the resultant amplitude will be given as this. right? So if y1 is equals to a sine omega t minus kx, and a1 is equals to a, and y2 is equals to a sine omega t minus kx plus theta, and a2 is also equals to a, then theta, see this is this these are two vectors separated by an angle, then the resultant will be equals to 2a cos theta by 2, right? This would be the magnitude of the resultant. So here we have 2a cos theta by 2. So what they are asking, the amplitude of the medium particle, the amplitude of the medium particle will be resultant of the two amplitudes which are at an angle theta, and that would be equals to 2a cos theta by 2. This formula you have studied in your vectors. That is, when two equal vectors are at an angle theta, then the resultant is given as 2a cos theta by 2. So the correct answer for your question number 25 is your option 4. Option 4. Right? Now coming to question number 26. Yes. Question number 26. Question number 26 says that if acceleration due to gravity at distance d, which is less than r, that is inside the earth's surface, for us from the center of earth is beta, then its value at a distance d above the surface of the earth will be. Okay, so we have to relate the acceleration due to gravity inside the earth's surface with the acceleration due to gravity outside the earth's surface, right? And they are saying that the acceleration due to gravity inside the earth's surface has to be taken as beta. So acceleration due to gravity inside the earth's surface will be given by gm upon r cube into d, right? Because we have the formula gm upon r cube into small r, and small r is being given to us as d. So what we finally get is your g, your acceleration due to gravity at d is equals to gm upon r cube into d, and this is to be taken as beta. This is what they are saying. Now at the surface at height d will be given as gm upon r plus d whole square, right? Now we will be replacing g, that is gm from here, and from here we get gm will be equals to beta r cube upon d. What we get, gm from this equation we get your gm is equals to beta r cube upon d, and we put this gm in this equation, that is for the acceleration due to gravity of the earth's surface, and then when we solve it we get acceleration due to gravity above the earth's surface as beta r cube upon d into r plus d ka whole square. That is in your option 4. So again this is simply formula based question, only rearranging your values, that's it, nothing very tricky. So next question number 27 says that a particle is executing simple harmonic motion and its velocity v is related to the position x as v square plus ax square is equals to b. Okay. So where a and b are positive constants, the frequency of the oscillation of the particle is. See, any particle executing SHM has a velocity, as we know velocity is equals to omega square under root of a square minus x square, right? A square minus x square. This is the thing. Now if we have here, we have the equation v square is equals to your what, v square plus a square, sorry, ax square is equals to b. This is what we have, right? Here we have, so v square plus ax square is equals to b, so v square is equals to b minus ax square. Now what we'll do, we'll take a common, so it will become your v square is equals to a into b by a minus x square. So in place of omega, when we compare it, we compare this with this, right? What we get in place of omega square is equals to a. So your omega will be equals to root a, right? Root a. So they are asking you the frequency. What is frequency? Frequency omega is 2 pi f is equals to root a. So your f will be equals to root a upon 2 pi. Simple, right? Again, simply comparison between the known formula and the given expression, right? So your correct answer is option 2, that is under root a by 2 pi. Coming to question number 28. Question number 28. Right, there are three sources of sound of equal intensity with frequency 200 Hz, 201 Hz and 202 Hz respectively. If all sound simultaneously, then beat frequency heard by listener will be, its answer will be 2 beats. See, there is a lot of calculations being done over here. It would be simple for you to understand it like this way, that see, the beat frequency between this and this sound, if suppose there are only these two sounds, then the beat frequency would be the difference in the frequency, which will be equals to 1 beat. Now, if it is between 201 and 202, again it would be 1 beat. Now, if it is between, let's say, 200 and 202, then it would be 2 beats per second, right? 2 beats per second. So, is there any other possibility? There is no other possibility. So, the maximum frequency is of 2 beats, right? Now, if maximum possibility is of 2 beats, obviously the correct answer should be a 2 beats, because 3 beats is not possible, 5 beats is not possible. 1 beat would occur, but this beat would occur twice a second, right? Or it may overlap with these 2 beats. Therefore, because this is the maximum frequency which could be attained using these three sounds, therefore your correct answer will be 2 beats per second. That is our option 2. And if you want to see the mathematical proof, you can just go to the mathematical calculations done over here. They have used a lot of trigonometry and differentiation. So I would not advise you to get into all these things, because a lot of mathematics. If you want, you can do it, right? But using your common sense, you can simply get the answer, because it's not a wide range of frequency. It is only of 1 hertz and 2 hertz. So we can easily understand that the beat frequency will be of 2 beat, right? So coming to question number 29. Question number 29 says that a loaded vertical spring execute SHM with a time period of 4 seconds, right? The difference between the kinetic energy and the potential energy of the system varies with period of. Alright. So, see, they are saying that the time period is 4 seconds. X is equals to A sine omega t, and kinetic energy is equals to half mv square, and potential energy is equals to half k x square. This is for a spring. Then kinetic energy, potential energy is equals to half k. Putting the value of x, we get a square sine square omega t, and we know that omega is equals to under root k by m, and omega is equals to 2 by t. 2 by t is t. We have 4 seconds. We put t as 4 over here. We get omega is equals to pi by 2 radian per second. Next, velocity is a omega cos omega t. Putting this in kinetic energy, so we get half m a square omega square cos omega t, and we have omega as pi by 2, right? And omega is equals to under root k by m, so k is equals to m omega square. Putting this value in 1, and subtracting and solving, we finally get your kinetic energy minus potential energy is equals to E max upon E max into cos omega 2 cos omega t, right? So your omega dash is equals to 2 omega. Now the frequency of the difference of kinetic energy and potential energy is equals to 2 omega, right? Now if frequency is equals to twice of omega, we had our omega as t. So omega dash is equals to twice of omega. So omega dash is equals to 2 pi by t dash, and omega twice of omega 2 into omega was pi by 2. So pi by 2. So this pi 2 and 2 cancels out. This pi and pi cancels out, and finally we get your t dash is equals to 2 seconds, right? So the frequency or the time period of this difference of kinetic energy and potential energy is equals to 2 seconds. So the correct answer for question number 29 is option 1, right? I hope this is understood to all. Again, I repeat, see, we have the expression x is equals to a sine omega t, and kinetic energy is equals to half mv square, potential energy is equals to half kx square. From here itself, we can say that v is equals to a omega. This is sine, so a omega cos omega t. This is x. Now this is v. For kinetic energy, we need half mv square. So squaring v from here, and we'll put here. And for kinetic potential energy, we need half k x square. That is potential energy of a spring. that is half k x square. So for x square, x we will take from here, that is a omega or a sine omega t. Square will square it and put it here. So potential energy becomes half k a square sine square omega t. We know that omega is equals to under root k by m, right? So from here we'll put the value of k as well, right? So omega is given as omega is equals to 2 pi by t. T is being given as 4 seconds. So from here we get omega is equals to pi by 2. Now putting v square in kinetic energy and solving it, we will again get an expression for kinetic energy. This is the expression for kinetic energy, which is again in terms of m a square omega square and cos omega t. Now we'll subtract these two expressions and solve it, and we finally get a time period as 2 seconds, right? So the correct answer for question number 29 is option 1, which is 2 seconds. Coming to question number 30. Question number 30 says that consider a planet moving around a star in an elliptical orbit with period t. The area of the elliptical orbit is proportional to. So area of an elliptical shape is given as A is equals to pi AB. Now here A is equals to B. A is equals to B. Then we get area is equals to pi A square. That is A is proportional to A square. Right? Now according to the Kepler's third law, the time period is proportional to A raised to the power of 3 by 2. Now small a, here we get A is proportional to A square, or we can say that your A square is proportional to A. So putting A as A square, here putting A as A square, what we get is your T is proportional to capital A raised to the power of 3 by 4. Wait a minute. So issue is, that is, here it will be 1 by 2. That is, if A is proportional to A square, then your A raised to the power of 1 by 2 will be proportional to A, and putting this value of small a in Kepler's law, we get your time period is proportional to capital A raised to the power of 3 by 4, right? So from here we get that A is proportional to T raised to the power of 4 by 3. So the correct answer for this question will be, question number 30 will be your option 1, that is T raised to the power of 4 by 3. Coming to the question number 31. A particle is executing simple harmonic motion. The ratio of the potential energy and the kinetic energy of the particle when its displacement is 1/3 of the amplitude will be. So kinetic energy upon potential energy. Again, the same formula. Total energy is equals to half k a square. Potential energy is equals to half k x square. X is 1/3 of the amplitude. So we are putting x is equals to a by 3. Solving it, we get k a square upon 18. Here we have k a square upon 2. Right? So the kinetic energy will be equals to, yeah, total energy is equals to this, out of which potential energy is equals to this, that is k square upon 18. So kinetic energy will be equals to total energy. Kinetic energy will be equals to total energy minus your potential energy, and this would result into 8 k a square upon 18, right? So the answer for question number 31 will be option what? Option 4. Yes, option 4. Right? Option 4. Why? Because kinetic energy is potential energy equals to ka square upon 18, and kinetic energy equals to 8 ka square upon 18. That is, kinetic energy is equals to 8 times of potential energy. From here we see. So the ratio of kinetic energies to potential energy will be equals to 8 is to 1. So correct answer is option 4. Now question number 32. Question number 32 says that reference intensity of the sound to at a point is 10 to the power of minus 12 watt per meter square, then intensity of the sound of 80 decibel will be. So they have given us I naught. I naught, that is the reference intensity of sound, is given as I naught is equals to 10 to the power of minus 12 watt per meter square. Taking log both the sides, This is for the formula for the loudness of the sound, which is calculated in decibel. That is 10 log I upon I naught is equals to, which has been given as 80 decibel, right? Putting it 80 decibel. And then removing the log and solving it, we get it as I is equals to, see, this 0 will go with this 0, and from here we get 10 raised to the power of 8 is equals to I upon I naught. I naught has been given to us as 10 to the power of minus 12, right? So we'll get I is equals to 10 to the power of 8 minus 12, which is equals to 10 to the power of minus 4. 10 to the power of minus 4 watt per meter square. So the correct answer will be option 3. So formula which we have used here is your 10 log I upon I naught is equals to your 80 decibel. That is the loudness of the sound in decibel. Next, coming to question number 33, the 3-point masses m each are moving a circle each with a speed of v under their mutual gravitational force. The distance between any two masses must be. Okay. So see, there are three masses, 1, 2 and 3. They are moving a circular path because of this their mutual gravitational force. Alright. So the force between this particle and this particle will be along this, and another force would be along this. So the resultant will be in this way. Similarly for this would be the centripetal force and this would be the centripetal force for this, right? So the force experienced will be equals to gm square into x square, and gm square into x square is for the both the forces. Suppose this is one of the particle, this is one force and this is the another force, and this is gm square upon x square, and this would also be again gm square upon x square, right? Now wait a minute, in the question they say are moving in the circle each with a speed this and under their the distance between any two mass must be. Now what we see here is that because all the masses are same and the scenario is a symmetrical scenario, therefore the distance between all the three masses will be same. That is, this will form an equilateral triangle, and therefore this angle will be equal to 60 degrees. Now again we have the same case that 1, 2, there are two forces or there are two vectors of equal magnitude and separated by an angle theta which is 60 over here. Then the resultant would be equals to your 2a cos theta by 2, that is 2 into g m square upon x square into cos theta by 2. Theta is 60 degree and cos 60 by 2 will be cos 30. Cos 30 will be equal to root 3 by 2. So this 2 and 2 cancels out. What we get the resultant force as your gm square into root 3 upon x square, right? Now your, yes, this is gm square root 3 upon x square. Now this is equals to mv square upon r. This is the centripetal force gm square upon r, where r is x upon root 3. This distance will be equals to x upon root 3. Why? Because this is the centroid, right? This is the centroid, or you can understand it like this, because if this is this is the equilateral triangle here, right? This is the equilateral triangle. This distance is your r, which we need to calculate. This angle is equals to 30 degree, right? And this is x by 2, right? So we need this, we have base, so cos 30 will be equals to your x by 2 by r, right? So r will be equals to From here we'll get r is equals to root 3 x by root 3. Solving this, you'll get r is equals to x by root 3. So here we have used the formula mv square upon r, that is the centripetal force. So this is the resultant magnetic force on one of the mass, and this is the centripetal force on one of the mass. Equating this, we'll get x is equals to gm upon v square. We'll get gm upon v square, right? I'm writing the things which we have used again. This is root 3 into gm square upon x square. This is the resultant gravitational force on one particle, and this should be equal to the centripetal force because they are in circular motion, and centripetal force is mv square upon r. So m into v square upon r. R is x upon root 3, and this would be whole square. Now solving this for x will give you the value of x as gm upon v square as your answer, right? So that is in your option 4. So the correct answer for this question number 33 will be option 4. Again, this is also formula based question directly. You should know the vectors first. The second question number 34 is, question number 34 says that if a simple harmonic motion is represented by d2x by dt square plus 4x equals to 0, then the time period of the resulting simple harmonic motion is. See the differential equation which represents your what? Which represents simple harmonic motion is d2x upon dt square is equals, plus omega square x is equals to 0. Omega plus omega square x is equals to 0, right? So if we compare this standard equation with the given equation, we get omega square is equals to 4, that is omega is equals to 2, and if omega is equals to 2, they are asking you the time period. So time period is equals to 2 pi by t is equals to 2. So from here we get t is equals to pi seconds. So t is equals to pi seconds is the correct answer for question number 34 is option 4. Coming to your question number 35. Question number 35. It says a sonometer wire is to be divided into 3 segments having fundamental frequency in the ratio 1 is to 2 is to 3. The ratio of the length should be. See, frequency is inversely proportional to length, right? And when frequency is inversely proportional to length, it means f1 is to f2 is to f3 will be equals to 1 upon L1 is to 1 upon L2. We can see it from here. Here you can see, right? f1 is to f2 is to f3 is 1 is to 2 is to 3, and this should be equals to 1 upon L1 plus 1 upon L2 plus 1 upon L3 is to 1 upon L3 is equals to 1 is to 3, 1 is to 2 is to 3. Solving this, you'll get L1 is to L2 is to L3 is equals to 2, 6 is to 3 is to 2. The major thing or the major concept which you have to remember over is the frequency is inversely proportional to length, right? F is inversely proportional to length, right? Why we have inversely proportional? Because f is equals to v by lambda, and lambda for a stretched string is been given in terms of L, right? For a stretched string, L is equals to 2 times of lambda, right? So the frequency will be f is equals to v upon 2L. So frequency is inversely proportional to L, right? So using the inverse proportional case, the final answer will be 4 is equals to 6 is to 3 is to 2. Coming to question number 36. Yes. Yes. So your question number 36 says that an escape velocity for body on the surface of the earth is 11.2 kilometers per second. If the earth's mass increases by increases twice of its present value and radius of the earth becomes half of the escape velocity, then the escape velocity becomes C. Escape velocity VE is equals to under root GM upon 2 GM upon R. 2 GM upon R, right? Mass is equals to, you can say, is your mass is your density into volume. Volume you can take as 4 by 3 pi R cube, right? Putting all these value and calculating, we get the formula for escape velocity in terms of density and radius, and that is your density is not to be there. They are saying that mass is increased twice. Okay, so simply we have to use, okay, wait. See, your VE is equals to under root 2 GM upon R. So this is made 2 times, so we'll multiply with 2, and this is made half, so we'll again multiply with 2, so it will become 2 times, right? Twice the present radius becomes the half of the escape. Okay, so from here we'll get your new escape velocity will be equals to 2 times your old escape velocity. So old was 11.2, so new will be 22.4. So the correct answer will be your option 1. Simple. Next, coming to question number 37. Question number 37. Yes, question number 37 says that in a closed organ pipe, the closed organ pipe, the first resonance occur at 25 centimeter. For a closed organ pipe, your frequency is equals to V upon 4L, right? And L is given as 25. At what length of the pipe the second resonance would occur? So for second resonance, if L1 is equals to your, so this is lambda, so lambda is equals to L by 4, right? So lambda is equals to 25 by 4. 25 by 4. They are asking you at what length second resonance. Second resonance for this case will be equals to your 3 4 by L. 3 into V upon 4L, right? So ऐसे बताऊं, you can see this calculation also. L1 is equals to lambda by 4 and L2 is equals to lambda by, that is 5, 3 lambda by 4, right? Your L1 is equals to lambda by 4 and your L2 will be equals to 3 lambda by 4, or your L2 will be equals to 3 times of L1, which is equals to 75 centimeter. This is so. So correct answer is option 4. Correct answer is option 4, right? Simply, or I would also like to see F naught is equals to V upon 4L and F dash, that is your second resonance, will be equals to what? 3V upon 4L, and this is equals to 3 times of F naught. No, just simply see. For L is equals to L1 is equals to lambda by 4 and L2 is equals to 3 times of lambda by 4. So if lambda by 4 is equals to 25, so 3 lambda by 4 will be equals to 75. So the correct answer is option number 4, that is 75 centimeters. So now coming to question number 38. Question number 38 says that tuning fork for known frequency 256 Hertz and 5 beats per second. Tuning fork known for frequency 256 Hertz makes 5 beats per second with vibrating string of piano when tension in the wire of the piano is increased by 2%, then beat frequency decreases by 2 beats per second. The frequency of the piano string before increasing the tension. Okay. See, if at 256 it was giving 5 beats, it means it was 251 hertz, right? Or it was 261 hertz. But when we are increasing the tension, the beats are decreasing. So when you are increasing the tension in the string, the frequency is supposed to be increased. So if frequency increases, this difference would increase from 5 to something more than 5. But if in case of 251 the frequency increases, the difference between the tuning frequency of the tuning fork and the piano string will decrease, and the beat frequency will decrease from 5 to something else, that is in this case is of 2 beats per second. Therefore the frequency will be 251 hertz. The correct answer is your option 1. I hope you understand. The tuning fork is 256 hertz. The tension in the string is increased because of the frequency has changed, right? Now initially the frequency was of the piano string was 251, or it could had been 261, because for both of these the beat frequency would be 5. Now if the tension is increased, frequency has to increase. So if frequency further increases from 261, the difference between these two would increase from 5. But in this case, if the frequency increases, the difference between these two will decrease. That's what is happening in the question. Therefore, the correct answer is 251 hertz, right? So coming to question number 39. Question number 39. Question number 39 says that the two particles of equal mass m go around a circle of radius r under the action of the mutual gravitational attraction. Okay, the speed v of each particle is. See, here there are two particles, they are attracting each other, and this is the center of the circle. And because they are attracting each other, the force of attraction, the gravitational force will act as a centripetal force. So the gravitational force is acting as a centripetal force. Gravitational force will be given as g m square upon 2r, because distance between them is 2r, and the centripetal force will be given as mv square upon r, right? Equating this and solving, we get v is equals to 1 by 2 under root g m by r, which is in your option 1. The correct answer for question number 39 is your option 1, right? Option 1, yes. Now coming to question number 40. Question number 40 says that the displacement of an object attached to a spring and executing simple harmonic motion is given by x is equals to 4 cos 4 pi t m. The time at which the maximum speed object first occurs during its the time at which the maximum speed object first occurs during is times. All right. So see, x is being given to us as x is equals to 4 cos 4 pi t. Now differentiating it to get the velocity, dx by dt will give you 16 sine 4 pi t. 16 pi 16 pi sine 4 pi t, right? Now for the maximum speed, this sine 4 pi t should be equals to 1. That means 4 pi t should be equals to pi by 2. and for 4 pi t to be pi by 2, t will be equals to 1 by 8 seconds. When we differentiate this, we will get 16 pi sine 4 pi t, right? Pi has been misprinted over here. This has not been printed. So 16 pi sine 4 pi t, and for this to be maximum, sine 4 pi t has to attain its maximum value, that is 4 pi t has to be equals to pi by 2, and equating this and solving, we get t is equals to pi 1 by 8 seconds. So the correct answer is option 4. Coming to question number 41. Question number 41. Question number 41 says that which of the following graph shows the variation of the acceleration due to gravity with depth h from the surface of the earth. With depth h, it is inverse, it is directly proportional, right? See, we have acceleration due to gravity h as gh is equals to g into 1 minus h upon r, right? So your g at depth is equals to g into r into h plus g naught, right? So here we see that there is a direct proportion with a negative slope. When we compare this, when we compare see this, when we compare this, we get slope as negative slope, right? Negative slope. So we have and a constant, negative and a constant slope. Why? Because g naught is constant and r is constant, is having negative value. So constant and negative slope is in option 3. So the correct answer is option 3, right? How we have done this is that acceleration due to gravity as depth has been given as gh is equals to g naught into 1 minus h upon r, right? Now multiplying it and solving it, we will get g is equals to g naught in g naught minus g naught h upon r, right? Now taking this side and this side, what we get, g is equals to minus g naught h upon r plus g naught. Comparing it with y is equals to mx plus c, we get m is equals to minus g naught upon r, which is a negative constant slope, and that is in option 3. So the correct answer for question number 41 is option 3. Question number 42. Question number 42 says that equation of a traveling wave is given by y is equals to 10 cos 1200 t minus 3x meter. The particle maximum wave velocity is particle's maximum wave velocity upon wave velocity is, all right. So see, y is equals to 10 cos 1200 t minus this. Comparing this with y is equals to a cos omega t minus kx, we get omega by k as your 1200 by 3, which is equals to 400 units. So wave velocity is your 400 units. Now particle velocity is your dv by dt. So dv by dt is equals to minus a omega sine omega t minus kx. When we differentiate this, we'll get this, that is minus a omega sine omega t minus kx. So from here we get a omega as, we will get this value as maximum when this quantity becomes pi by 2, right? For this to be 1. So V of the particle as maximum will be equals to a omega. So A is given to us is as 10. From here we can say that A is equals to 10, and omega from here again we can say is 1200. So when we multiply it will give us 12,000 units. So comparing the ratio, that is the particle velocity upon the wave velocity, it comes as 30. So the correct answer for question number 42 is option 1, that is 30, right? So coming to your question number 43. Question 43 says when a particle executes simple harmonic motion, the nature of graph of acceleration as a function of velocity will be, see, when velocity increases, acceleration decreases. It's a restoring force, right? So when you draw a graph or you don't understand, like see, you understand from here, that is a is equals to, sorry, x is equals to a sin omega t, velocity will be a omega cos omega t, right, and acceleration will be equals to minus a omega square sin omega t. Now this equation from second and third, what we get is your b square upon a omega whole square plus a upon omega square a is equals to 1, which is the equation of ellipse. Therefore the shape will be an elliptical shape, right? So what we have done here is, see, a omega cos omega t, and this is minus a omega square sin omega t, right? So from second and third v square upon a omega. Okay, now if you see, we have v, we can write v upon a omega is equals to cos omega t, and from third we can say that your a, that is acceleration, upon minus a omega square is equals to sin omega t. Now sin square theta plus cos square theta is equals to 1. So in place of sin square theta we will write square of this. In place of cos square theta we will write square of this. That's what we have done in this step. That is v square upon a omega whole square plus a square upon omega square a whole square is equals to 1, which is an expression for ellipse. Therefore it will give you an elliptical shape. That is when we are drawing a graph of acceleration as a function of velocity, right? This is acceleration as a function of velocity. So the correct answer for question 43 is option 3. Coming to question number 44. Question number 44 says that an artificial satellite moving in a circular orbital around the earth has a total, that is kinetic energy plus potential energy, E naught. Find its potential energy and kinetic energy respectively. See, we have a relation, that is potential energy is equals to twice of the total energy, and total energy is equals to minus of kinetic energy, right? Using these two relations, we can simply write that if total energy is E naught, then potential energy will be equals to 2 times of E naught, and if total energy is E naught, then kinetic energy will be equals to minus E naught, right? And this option is, they are asking your potential and kinetic, that is 2 E naught and minus E naught. 2 E naught and minus E naught is in option 3. So the correct answer is option 3. Question number 44 is option 3. Question number 45. Question number 45 says that three waves y1 is equals to y1 is equals to 2 sine omega t minus pi by 3, 2a sine omega t minus pi by 3, y2 is equals to 2a sine omega t plus pi by 3, and y3 is equals to minus a sine omega t. So all the three waves are having three different amplitudes, 2a, minus a, and 2a, right? But the frequencies are omega, omega, and omega. They interfere each other. The amplitude of the resultant wave will be. So again, for interference, you simply add them. That is, y is equals to y1 plus y2 plus y3. y1 is equals to 2a sine omega t minus pi by 3. y2 is equals to 2a sine omega t minus plus pi by 3, and y3 is equals to minus a sine omega t. Applying our trigonometry here, finally we get a is equals to y is equals to a sine omega t. Right? How? This is how, because see, if you see these two are exactly in opposite phase. How you don't understand it? Simply these two are these are the calculations, and from this calculation we get y is equals to a sine omega t, right? Or if you want to understand in the other way, we can say that, yeah, the correct answer for your question of 45 is your option 1, that is the resultant wave we are getting y is equals to a sine omega t. So the amplitude of the resultant wave is your a. So the correct answer for question 45 is your option 1, that is the amplitude of the resultant wave will be equals to a. So correct answer is option 1. Coming to question 46, if the radius of earth reduces by 4% and the density remains the same, then the escape velocity changes too, right? So again here we will have to find the, or we should know the formula for escape velocity in terms of radius and your radius and density. So see, we have escape velocity v is equals to under root of ve is equals to 2 g m upon re. M is the mass of earth, right? So mass of earth can be written in terms of density of earth into 4 by 3 pi r e cube, right? Using this, in this will get our relation between escape velocity and radius and density as this, that is escape velocity is equals to under root 8 g upon 3 pi r cube rho, right? So what we conclude from here is, see, they are asking you reduce, radius has been reduced and the density remains same. So if radius is changing, 8 is constant, g is constant, 3 is constant, pi is constant, and density remains same, only radius is changing. So what we find from here is that escape velocity is inversely proportional to root of r cube, right? It's inversely proportional to root root of r cube. So if the radius is reduced by 4%, if the radius is reduced by 4%, then the escape velocity will also reduce by 4%, right? It's r square, no? R square. So since it's r square, we find that v is inversely proportional to r. Now, if v escape velocity is inversely proportional to r, if v is increasing by 4, sorry, r is reduced by 4%, ve will increase by 4%. Therefore, a correct answer will be 4%, reduced by 4%. So the correct answer will be your option 3. Give me a second. Option 4 is increased by 4% and is proportional to r. Okay, yes, is proportional to r. Sorry, my mistake. It is proportional to r, right? Because this r will be in the numerator. So when we derive a relation between your escape velocity ve, we get it as it's proportional to root of r square. That is, escape velocity is directly proportional to r. So if radius is reducing by 4%, the escape velocity will also reduce by 4%, right? Now coming to question number 47. Question number 47 says that a particle executes a system according to the equation this, that is x is equals to 10 cos 2 pi t plus pi by 2, where t is in seconds. The magnitude of the velocity of the particle at t is equals to 16 seconds is. So they have given x to us, right? So at t is equals to 1 by 6 seconds, x will be equals to 5 by minus 5 by root 3. Putting t is equals to 1 by 6 here and solving it, we get x is equals to minus 5 by root 3. And velocity is being given as v is equals to omega under root of a square minus x square. We have a as 10 over here and we have calculated x as minus 5 by root 3. Putting these value over here, we get v is equals to your 10 pi, and 10 pi is equals to 31.4 centimeter per second. So it will be option 4, that is 31.4 centimeter per second, right? Now coming to question number 48. Question number 48. Question 48 says that a uniform rope of mass 0.1 kg and length 2.45 meter hangs from a ceiling. The time taken by the transverse wave to travel the full length of the rope is. So for this, we have to use the formula, that is the velocity of the wave at a distance in a rope is given by V is equals to under root of T upon mu, where mu is the mass per unit length, right? So tension at suppose the mass total mass of the rope is capital M and total length is L, and the tension at a distance x at the bottom of from the bottom is given as T is equals to M by L into x into G. So using this formula, putting the value of T and putting the value of mu will be M by L and T will be equals to M by L into x into G. We get V is equals to under root Gx, right? V is equals to under root Gx. Now, so V is equals to dx by dt. V is equals to dx by dt, that is equals to under root Gx. So under root Gx is equals to dx by dt. So your dt will be equals to dx upon under root Gx. Integrating both the sides from 0 to L and solving it, we get our t is equals to 1 second, right? So the correct answer will be your option 4, that is will be equals to 1 second. Coming to question number 49, infinite number of point masses each equal to the mass of mass m equal to m are placed at x is equals to 1, x is equals to 2, x 3, 4, 5, 6, 7. Sorry, x is equals to 1, then double is 2, and then its double is 4, and its double is 8. That's twice the distance. Now, what is the total gravitational potential at x is equals to 0? So, see here, they have used the formula of sequence and series. So, here the potential V naught will be equals to G m upon 1 minus Gm upon 2 minus Gm upon 4 minus Gm upon 8 minus Gm upon and so on. And when we take minus Gm common, we get a what? We get a GP, that is geometric progression, that is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, where A is equals to 1 and R is equals to 1 by 2, and we have to find the sum of this progression up to infinity. So that for that formula we have S is equals to A upon 1 minus R, right? 1 minus R. So using this formula here, we get the sum of all the distances, that is sum of this geometric progression, and then we multiply with minus Gm and we get our answer as minus 2 Gm. So the correct answer for question number 49 is your minus 2 Gm, that is option 2. Coming to question number 50. Question number 50 says that the standing waves are produced in a 10-meter long stretched string fixed at both ends. If the string vibrates 5 segments and wave velocity is 20 meter per second, the frequency is. So if it is a stretched string, that is fixed at yes, if it is fixed at both ends and it is vibrating with 5 segments, means 1, 2, 3, 4, 5 segments, right? So this is equals to lambda, this is equals to lambda, and this is a half a lambda, right? So the length is equals to 5 by 2 lambda. Length of the string is equals to 5 by 2 lambda, means 2.5. This is 1 lambda, this is 2 lambda, this is half lambda. So the total length is equals to your 2.5 lambda, which we can write it as 5 by 2 lambda, right? So length is equals to 5 by 2 lambda. So putting L is equals to 10 as given in the question, we get lambda is equals to 4. Now if we have lambda is equals to 4 and we have velocity as 20, solving it we get frequency as 5 hertz, right? Frequency as 5 hertz. We calculated lambda from the length and the segments of the wave frequency, standing frequency, and from lambda and the velocity given in the question, we simply calculate the velocity and the frequency. Frequency comes as 5 hertz, which is the option 1 for question number 50. The correct answer for question number 50 is option 1. I hope all the explanations for all the 50 questions is clear to all. If you have any doubt, please put your comments in the comment box and let me know if you have any doubt, and if there are any mistakes or anything which has been missed out, or if you have not understood it, please tell me in the comment box. Please put your comments in the comment box so that the problems could be rectified, right? This is all from my side. Thank you.